The diesel engine has been around for many decades, but has gained huge popularity and growth in the last 20 years. The diesel engine has been noted as a workhorse. The additional torque and horsepower created by diesel combustion is at the heart of its success. The fact that there was little federal regulation on tailpipe emissions led to a great deal of attention as the number of diesel vehicles started to grow. The first of the regulations came with a change to lower sulfur content diesel fuel. Since then, the federal government, as well as many state governments, have called on diesel-powered vehicle manufacturers to update their emission control systems on these vehicles. Today, these diesel-powered vehicles comply to emission standards that are equal to many gas-powered vehicles. Our goal here is to familiarize you with the diesel emission systems and their individual components. Some of these are very similar to gasoline engine components, and some are unique to diesel applications. This will include the entire after-treatment system, as well as all of the individual sensors and reductant delivery. Having a better understanding of what makes up the different emission systems will help when discussing needed items for proper repairs. Anytime you can talk intelligently with your customer about specific systems and components, you will build a reputation of being the go-to person for all of their needs. This slide shows the need for keeping up with the new technologies as they relate to the diesel world. The information is based on 2018 vehicle sales and includes all passenger and light truck models that use alternative means over gasoline only. Included is everything up to and including 1-ton pickups. The graph on the left shows that 43% of all alternative fuel vehicles were diesel powered, making up the single highest type. The closest type behind that is hybrid at 28%. Diesel is the only category that has growth in all 4 vehicle types: sedan, SUV, pickup, and van. The question comes up, why diesel? The motivation by manufacturers to go to diesel is driven by the corporate average fuel economy, or CAFE standards, set up by the federal government. The goal is to reach 54.5 miles per gallon by 2025. That may be extended somewhat, but at this point, 2025 is still the goal. The question then becomes, how do we get there? The gasoline internal combustion engine appears to have reached its maximum efficiency, which falls short of the 54.5 miles per gallon as mandated. Diesel is a viable option to gasoline. It is 30 to 40% more efficient than gasoline, which results in lower fuel consumption when doing the same amount of work. The new generation of diesel technology feels right at home in showrooms alongside advanced gasoline, battery electric, and plug-in hybrid vehicles. We know it's not a one-fuel-fits-all world, and for consumers, diesel is a proven performer that delivers real benefits: high fuel efficiency, great driving range, no sacrifices in vehicle size, fueling access, towing capabilities, or performance. This generation of diesel vehicle is among the most scrutinized, tested, and most improved in the world. Looking forward, we expect diesel registrations to rise, especially in SUVs, trucks, and vans, in part due to full-year availability of the newest models. As seen with the 2018 and 2019 model years, manufacturers added more than 10 new diesel models to the U.S. market across the most popular vehicle segments. The greatest signals of continued growth? New diesel options in full-size pickup trucks, among the most popular selling class of vehicle in America: the GMC Sierra Silverado 1500, the Ford F-150, and Ram 1500. In the lineup of available alternative fuels, diesel remains the only one with choices in all vehicle segments: sedans, light trucks, SUVs, vans, and even luxury performance vehicles. CAFE standards are not the only regulations that the OE must adhere to. The tailpipe emissions are under even more scrutiny. Now let's get a look at the components that the OE manufacturers rely on to meet the tailpipe emission standards. You will need to familiarize yourself with new terminology when dealing with later model diesel applications. With names like diesel oxidation catalyst, diesel particulate filter, selective catalyst reduction, diesel exhaust fluid, and many new types of sensors that are used to monitor and control the function of these units. We will use this Dodge Ram Cummins 6.7-liter aftertreatment for our example. The aftertreatment system on this application shows the different components that make up the complete system. The diesel oxidation catalyst, the diesel particulate filter, and selective catalyst reduction components are the heart of the aftertreatment system. Each performs a unique function and are placed in the exhaust flow in a specific order as laid out by the OE manufacturer. This specific order is similar to writing a formula where the ingredients must be added in a specific sequence. As each component performs its job, it is helping the process performed by the next component. The DOC, or diesel oxidation catalyst, is the first device in the aftertreatment system. It is a flow-through honeycomb ceramic filter that contains precious metals to start the oxidation of hydrocarbons, carbon monoxide, and unburned fuel and oil. The DOC converts the carbon monoxide and hydrocarbons into carbon dioxide and water vapor. This function optimizes the remaining gases that assist the remaining components to do their job better. The DPF, or diesel particulate filter, operates by trapping soot particles from the engine exhaust, preventing them from exiting the tailpipe. The particulate filter is designed to trap and retain the solid particles until the amount of soot reaches a preset level, at which time the PCM recognizes the amount of restriction the soot is causing and commands the regeneration process. This process uses raw fuel to burn off the soot, where the DPF becomes a furnace. Over time, the ash left over from the regeneration process can build up and cause flow issues inside the DPF, resulting in the need for replacement. The SCR, or Selective Catalyst Reduction Unit, is made up of precious metals and ceramic materials as a catalyst in the control of NOx. The actual function of the SCR requires a reductant. The reductant used is an automotive-grade urea. The urea is introduced through a doser valve ahead of the SCR, where the urea is injected directly into the hot exhaust stream where it is vaporized. Once vaporized, the ammonia in the urea attacks and breaks down the NOx into nitrogen, H2O, and a small amount of carbon dioxide. On the same 6.7-liter Dodge Ram Cummins engine are the many different sensors and components that you will need to be familiar with. Moving from right to left, following the flow of the exhaust, let's look at each of the sensors and components. First, the NOx-1 is located immediately after the turbocharger in the exhaust stream. This unit senses the amount of NOx and oxygen present in the raw exhaust. EGT1 measures exhaust temp in the raw exhaust stream. EGT2 monitors the exhaust temp at the DOC. The differential pressure sensor measures the pressure difference between the inlet and outlet of the DPF and is monitored by the PCM. DEF tank and doser valve. DEF is stored in the tank, which includes a heater and pump. Fluid is delivered to the doser valve, or DEF injector, and sprayed into the hot exhaust stream. EGT3 monitors exhaust temp prior to the SCR. EGT4 monitors temp inside the SCR, and EGT5 monitors temp after the SCR. NOx-2 monitors the amount of NOx and oxygen being released out of the tailpipe. NOx sensors are a complicated, high-tech component. Most applications use an upstream and a downstream unit. Others use only a downstream unit. The module portion of the unit is usually sold as an integral part of the total unit, and others sell the module and the actual sensor separately, as on some Ford applications. Diesel NOx sensors are dual purpose in that they are used to measure both the oxygen level in the exhaust as well as the NOx content. The measurements take place in two separate chambers in the sensor, and the exhaust gases flow sequentially through one and then into the other. Gases flow from the exhaust stream through a diffusion barrier to reach the first chamber, which pumps the free oxygen out using a simple oxygen sensor. With the free oxygen removed, the NOx is then left to migrate through another diffusion barrier and into the second measurement chamber. At this point, the NOx molecules encounter a catalytic element, which breaks them into nitrogen and exhaust gases. A second simple oxygen sensor is then used to pump the newly generated oxygen out of the chamber, and this electric current is used to calculate the NOx levels in the exhaust. The residual nitrogen gases then flow out of an exhaust port in the second measurement chamber. When using two NOx sensors in a urea SCR system, the upstream sensor is used to estimate what amount of DEF needs to be injected ahead of the SCR catalyst to achieve optimal NOx conversion. The downstream or post-catalyst sensor is then used to check the results. In some cases, such as the 6.7-liter Ford, only one NOx sensor is used post-SCR. NOx sensors were first found on the 2010 model year of GM pickups and vans, followed by Ford and Dodge in 2011. These units are critical to the amount of NOx being released out of the tailpipe. NOx is considered to be one of the most harmful emissions from fossil fuel-powered vehicles, resulting in their strict control. These units will become an everyday sale item in years to come. They can fail due to exhaust components building up on them, hindering their functionality. Water intrusion is another big issue that can cause failure. This is more common on the downstream unit, and it is very near the rear tire and wheel assembly. When the vehicle is driven through a large puddle of water during the rainy season or during spring breakup in snowy areas, that water can easily splash onto the sensor. If the vehicle is in an area where roads are salted, then the failure rate will most likely be higher. Damage to the cable can also occur from road debris or if the vehicle is driven off-highway. EGT or exhaust temp sensors are not only an important input for control of the aftertreatment system, but are also used to protect the catalysts and filter from damage caused by overheating. The PCM constantly monitors each of these sensors to verify system functionality during normal driving as well as during the regeneration process. With regeneration temperatures reaching 600 degrees Celsius, these units are exposed to extreme temperatures and raw exhaust that can and will cause them to fail over time. These components will become commonly replaced items. Diesel aftertreatment system operation and onboard diagnostics require close monitoring of the temperatures across the catalyst and filter. In this Cummins example, each component has an EGT sensor at the inlet and outlet. With these sensors, the onboard system can determine the temperature rise or fall across each component. The diesel particulate filter sensor uses low-power radio frequencies, or RF signals, to transmit and receive RF signal through the filter. Soot and ash accumulation levels, as well as filter failure symptoms, can be directly measured by the change in response of the RF signal. If the pressure differential exceeds a specific threshold, the PCM recognizes that the buildup in the DPF has reached a critical amount requiring a regeneration to occur. This is when the PCM will initiate an active regeneration process. Each manufacturer has their own way of determining the pressure drop or restriction across the DPF. For example, Duramax samples the pressure before and after the DPF using two metal pressure taps and hoses that connect them to a DPS. Mounted away from the heat of the exhaust system, the DPF reports the pressure difference to the ECM. Diesel exhaust fluid, or DEF, is a non-hazardous solution which is 32.5% urea and 67.5% deionized water. DEF is sprayed into the hot exhaust stream of diesel vehicles to break down dangerous NOx emissions into harmless nitrogen and water. The ammonia component of the urea vaporizes in the hot exhaust. This vaporized ammonia breaks down the NOx molecule into nitrogen and H2O, both harmless and useful gases individually. DEF is not a fuel additive and should never come into contact with diesel fuel. The DEF pump is just that, a device that channels DEF fluid from the DEF tank to the DEF injector, where it is dosed into the exhaust during the after-treatment process. DEF can be corrosive to most metals, so the pumps are primarily made up of plastics, which do not wear as well as metal, decreasing their lifespan. In addition, the electrical connectors are prone to corrosion buildup, causing the unit to malfunction. Next, commonly called the DEF heater, this unit is located in the DEF or diesel exhaust fluid tank and actually contains the pickup tube for the reductant pump module, an electrical heating element, and a temperature sensor, as well as an electrode type level sensor. Ford terms the whole unit the reductant heater and sender assembly. Both the GM and Ford versions are very similar in appearance. However, the Dodge unit cannot be serviced with individual components like the Ford and GM units can. The Dodge unit is sold and serviced as a complete modular unit. The DEF injector is used to inject small quantities of diesel exhaust fluid into the exhaust, where it vaporizes and decomposes to form ammonia and carbon dioxide. This is where the ammonia attacks and breaks down the NOx gases to nitrogen and H2O. Being in the hot exhaust stream, the injector nozzle is susceptible to buildup, which can cause the spray pattern of the DEF to become erratic. If the spray pattern is not correct, it can form droplets that will not vaporize, allowing liquid DEF to flow through the exhaust system and will not be able to do its job of breaking down the NOx molecules. The inset shows a contaminated nozzle. DEF is available under a multitude of brand names. It is important to follow the instructions written by the manufacturers in regards to properly storing product when it is stocked in quantities. Putting it in the window display in hot temperatures is not recommended, nor is allowing it to freeze. Sticking with a proven brand is also recommended. Any subpar product may contain impurities that can adversely affect the way it works. In 2011, GM came out with a new idea to enrich the exhaust to assist the aftertreatment system. The 6.6-liter LML incorporated a ninth fuel injector located in front of the diesel oxidation catalyst in the turbo downpipe. It receives its fuel from the high-pressure fuel injection pump at the front of the lifter valley and injects diesel directly into the exhaust stream during active regeneration. By injecting raw fuel directly into the hot exhaust, the diesel fuel assists in the regeneration or burn-off process in the DOC. When the PCM makes the decision to inject fuel, it is called active regeneration. When the technician uses a scan tool to force generation, it is called passive regeneration. There are two part numbers available for this component. One covers 2011 to 2016, and the other 2017 and later. This indirect system is unique to the GM Duramax, while the other manufacturers use a post-injection process where raw fuel is injected during the exhaust stroke, allowing raw fuel to enter the exhaust stream. The function of the EGR valve is to recirculate small amounts of exhaust back into the combustion chambers of the engine in order to decrease the combustion temperature, thereby reducing the formation of smog-producing nitrogen oxides. EGR valves can malfunction by becoming stuck open or closed due to carbon buildup. The EGR system is vital to the emission system when it comes to the reduction of NOx gas. This gas is formed in the combustion chamber due to compression and high heat, both of which are prevalent in a diesel engine. By reinserting exhaust gases into the combustion chamber, the gases can cool the combustion chamber, and because the exhaust gases are oxygen starved, it has little effect on the actual combustion process. The flow of exhaust gases back into the combustion chamber must be carefully metered to achieve the desired goal. Therefore, the PCM controls flow of EGR. The EGR cooler is a component used to lower the temperature of the exhaust gases that are recirculated by the EGR system. The EGR system recirculates exhaust gases back into the engine in order to decrease the cylinder temperatures and NOx emissions. EGR coolers can malfunction by becoming clogged or closed due to carbon buildup or poor maintenance. Part of the maintenance is to maintain the engine coolant. Engine coolant is the medium used to cool the hot exhaust gases before being introduced back into the engine. If an engine cooling system is not properly maintained, the EGR cooler can become damaged, causing exhaust gas to enter the cooling system, or coolant can enter the EGR system. Neither scenario is good. We hope you now have a better understanding of the potential business that is available when dealing with diesel customers. It's not only about injectors, pumps, and turbos. There is a tremendous opportunity to be your customer's source for their diesel emission needs. We also hope that you now have a better understanding of what is involved in the diesel emission systems, from DOCs to DEF and everything in between. The potential for sales of aftermarket treatment components is just beginning and has a huge growth potential. These are items that are easy to stock, easy to sell, and have a high demand. Diesel-powered vehicles are going to be around for years to come, and we may very well see even more diversity in the types of vehicles that offer diesel engines as an option. That being said, we will be here to supply you with the parts that your customer needs and the educational information that you need to meet your customer's needs.